Hello students, in the previous module we discussed about dimensions. Now we are going to discuss about what are the applications of dimensional analysis.
Next, what are the uses of dimensional analysis? First use is conversion of one system of units to another system of units. Second is check the correctness of the equation. Third is to derive the relation between physical quantities. We will discuss one by one. First one, conversion of one system of units to another system of units. So we will see how can you convert one system into another system. See, you know about SI system and CGS system, or whatever the system they are given, we can convert the dimensional quantity, that means unit, into one system from the another system, that physical quantity from one system into another system. That means 1 meter is equal to 100 centimeter, that you all know it. When we go for complex unit like the unit of force in CGS system it is dyne, and SI system it is Newton. So what is the relation between Newton and dyne? Like work, in CGS it is erg, and in SI it is joule. The relation between erg and joule. So for these all relations we will take the help of dimensional analysis. You know it, 1 meter is equal to 100 centimeter. 1, that is the numerical part. Meter, that is the unit part. 100, that is the numerical part. Then centimeter, again it's a unit part. But dimensionally both are same, so we are writing 1 meter is equal to 100 centimeter. So we will express the dimension of a physical quantity here, that is x is equal to NU. N is the numerical part and U is the unit. Unit in one system and unit in the another system. If we want to convert one system to another system, first we express the dimension of the physical quantity. X is equal to N1, M1 raised to A, L1 raised to B, T1 raised to C. This is the dimension in one system of unit. Next, M2, L2, T2 with the fundamental unit of physical quantity X in second system. And here the numerical part N2 is changed because we are going to another system of unit. Then N2, M2 raised to A, L2 raised to B, T2 raised to C. But you remember the powers remain same because these are the same fundamental quantity. Same fundamental quantities we expressed it. Now we will equate both the equations. N2 into M2 raised to A, L2 raised to B, T2 raised to C. This is equal to N1, M1 raised to A, L1 raised to B, T1 raised to C. So when we equate both the equation, you will get N2 is equal to N1, M1 by M2 raised to A, L1 by L2 raised to B, T1 by T2 raised to C. Here M1 means the unit in one system, M2 in another system. The same way for length and time. We are going to solve one question. Convert 10 joules to erg using the dimensional analysis. 10 joules to erg. First step is joule is the unit of which physical quantity? Joule is the unit of energy, work. Then you write the dimension of energy, that is M1 L square T minus 2. Then you know the fundamental equation we derived previous, that is m1 raised to a, l raised to b, t raised to c. So you can compare that equation with this. So here a is equal to 1, b is equal to 2 and c is equal to minus 2 that we have written. Now we have to convert 10 joules to erg. That means here N1 is equal to 10 joules. Then M1, joules means it is the SI unit of work or energy. SI unit, fundamental quantity, mass is in kg, length is in meter, time is in second. So we will write here M1 is equal to 1 kg, L1 is equal to 1 meter and T1 is equal to 1 second. Then CGS system. CGS system, we don't know how much is the numerical part, that only we have to calculate. So into question mark. Then the fundamental quantities, you know the unit of mass is gram and length is centimeter and time is second only. Now you know this formula we already discussed in the previous session, that is N2 is equal to N1 into M1 by M2 the whole raised to A, L1 by L2 the whole raised to B, T1 by T2 the whole raised to C. We put the value here. You know that 1 kg that is equal to 1000 gram, 1 meter 100 centimeter, second, once both are seconds, no problem. So 10 into 10 to the power 3 into 10 to the power 4, that is equal to 10 to the power 8. That means finally we got 1 joule is equal to 10 to the power 8 erg. So how to solve the question? After getting the question, first you have to see this is the this unit is for which physical quantity. Then next step, write the dimension of the physical quantity. Then compare it with the m raised to a, l raised to b, t raised to c. Then write a, b, c. Then we will write both systems, one system here, another system here. Then the numerical part and the unit part we will write. Then use the formula here, and from that formula you can calculate the value.